So let's welcome in next lecture of MIT 201, that is integral calculus. So in previous lecture, so we have seen reduction formula 3, that is integration of x raised to m cos nx dx, and that is equal to x raised to m sin nx n divided by n plus m into x raised to m minus 1 into cos nx divided by n square minus m into m minus 1 divided by n square into integration of x raised to m minus 2 into cos nx dx. See, so first, using integration by parts, we derived this reduction formula, and then, so using this reduction formula, we evaluate certain integrals. So first, we derived the value of integration, that is integration x cube cos 3x dx, using method of integration, that is reduction formula 3. Yeah, yes, it is reduction formula 3. So in last lecture, so I have given two examples to you as exercise. So hope so all you solve will solve. If not, you can solve this, or if solved, then there is no problem. So if you have any queries, so you can directly message me or call me. So next, that is reduction formula number 4. So in next lecture, that is lecture number, just minute. So it is lecture number 5. So in this lecture, we'll see next reduction formula, that is reduction formula 4. So what is next reduction formula? So reduction formula 4 is that integration of x raised to n e raised to minus x dx, and again using integration by parts, so we can derive this reduction formula as, that is minus x raised to n e raised to minus x plus n times integration x raised to n minus 1 e raised to minus x dx. So this is fourth reduction formula. Yes, so it is reduction formula number 4. Yeah, so first we'll derive. So derivation will quite simple, straightforward. So directly using integration by parts, so you can write it. So what is, so derivation of proof you can write. See, so using integration by parts, so we have, or we can write. See, so you can write integration x raised to n e raised to minus x dx as, so that is, you can consider x raised to n as function u and e raised to minus x as function v, that is first function x raised to n, and second function, that is e raised to minus x. So using rule of integration by parts, so first function will be as it is, and second function, so we are integrating second function, that is integration of e raised to minus x. So what is that? It will be minus e raised to minus x. So this is u into integration of v minus, so in big integration, so in that you are differentiating first function, that is n times x raised to n, so this is derivative of, So n minus 1. So this is derivative of x raised to n and integration of second function, that is e raised to minus x. So it is minus e raised to minus x and dx. So you can write it, you can simplify it and you can write in simple form as, so it will be x raised to, so minus x raised to n e raised to minus x. So this minus and this minus will be plus, and n you can take outside of integration, that is x raised to n minus 1 e raised to minus x dx. So this will be the required reduction formula, that is reduction formula number 2. So next you can consider simple example of this reduction formula, or yeah, so you can consider illustrative example. Yeah, just a minute. Yeah, so you can consider simple illustrative example. So this pen is jumping. So using method of integration, evaluate the integration of x square e raised to minus 2x. Yeah, or it's okay. Yeah, dx. Very simple. So solution, we have reduction formula, that is reduction formula 4, that is integration of x raised to n e raised to minus x dx equal to, that is minus x raised to n e raised to minus x plus n times integration of x raised to n minus 1 e raised to minus x dx. So you can call it as suppose equation number 1. So this is reduction formula 4, which we have just written here. So you can use this reduction formula. It is just illustrative example on this reduction formula number 4. So see, so putting n equal to 2 in an equation 1, so we obtain, or we can write, that is integration of x square e raised to minus x dx will be equal to, so minus, it is x square e raised to minus x plus, so n we are taking 2, so it is 2 times, so x raised to 2 minus 1, that is x just, and that is e raised to minus x dx. So you can call this equation as equation number 2. So next, so again footing, so we want value of this integration. So after finding value of this integration, we can substitute this integration in equation number 2 and we will get required integration. So let us put, so again footing, see, so n equal to 1 in an equation 1, so we get, see, so that will give us integration of x e raised to minus x dx, and which is nothing but minus x e raised to minus x plus, so we are putting n equal to 1, so it will be 1 times integration of, so x raised to 1 minus 1, that is 0, so it is just integration of e raised to minus x dx. So you can simplify this and you will get, so what is value of this integration, so it will be minus x e raised to minus x minus e raised to minus x. So you can call this equation as equation number 3. So next, substituting equation 3 in equation 2. So we get the value of integration, that is integration of x square e raised to minus x dx, and which is nothing but minus x square e raised to minus x plus 2 times. So value of this integration, so it is nothing but that is minus x e raised to minus x minus e raised to minus x. Yeah, so we can simplify this, so it will give us minus x square e raised to minus x plus, so this minus plus, it will be minus 2 times x e raised to minus x, and it will be minus 2 times e raised to minus x. So e raised to minus x you can take common, so it will give us c, or you can take minus e raised to minus x common, so it will be minus e raised to minus x. So in the bracket it will be x square plus 2x plus 2. So this is the required integration, required value of given integration. So this will be required answer. So very simple, so you can solve so different examples using this reduction formula. So you can, I will give some homework on this reduction formula, so you can solve these examples at home and you can send pics of solutions of these problems. So you can do homework. Evaluate the following integrals using methods of integration. So first, so integrate, suppose x cube e raised to minus x dx. Second, evaluate integration of x raised to 5 e raised to minus x dx. Then evaluate, so I'm taking, yeah. Third, evaluate integration of, suppose x raised to 4 e raised to minus x dx, and it is from 0 to 1. And fourth, evaluate integration of x raised to 7 e raised to minus x dx. So do these examples at home. So yeah, this is homework on this fourth reduction formula. Yeah, so next reduction formula, it is, so this fifth reduction formula. Reduction formula number 5, and it is integration of, see, integration of x raised to m into log x its power m dx, and the value of this reduction formula, sorry, value of this integration using reduction formula is that, see, so it is equal to x raised to m plus 1 divided by m plus 1 into log x its power n minus n upon m plus 1 integration of x raised to m log x its power n minus 1 dx. So this is fifth reduction formula. So first we will derive this reduction formula and then we will solve some illustrative examples on this reduction formula. So yeah, so derivation of proof you can see. So proof. So using integration by parts, using integration by parts, so we can write integration of x raised to m into log x its power n dx. So let us consider integration by parts, and in integration by parts, so rule of integration by parts, so which function should be first function and which function should be last function. So here I'm considering so log x function. So let us see. So I'm considering log x raised to n as a function u and x raised to m as a function v. So I can write this integration as, let us see. So I'll write it as, so log x its power n into x raised to m dx. So using integration by parts, so let us see. So we are integrating first function. So this first function and second function will be remains as it is. So log x its power n. So what is the integration of, yeah, what is the integration of what I'm doing here? Yeah, it's okay. Sorry, just a minute. Yeah. So what should be first function and what should be second function? So x raised to m, yeah, is second function and log x is first function. See, so this is first function and this is second function. So I will write it as, so log x its power n into x raised to m dx. So first function, that is u, and second function, that is v. So first function remains as it is, so it will be log x its power n into, so integration of second function, that is x raised to m plus 1 divided by m plus 1. So what is integration of x raised to m? So it is x raised to m plus 1 divided by m plus 1. So minus, see, so integration, so derivative of first function, that is derivative of u. So what is that? So it will be n into log x into derivative of log x. So it will be 1 upon x. So it will be divided by x, and what is the integration of x raised to m plus x raised to m? So it is x raised to m plus 1 divided by m plus 1 dx. So you can simplify this and it can be written as, c. So you can write it as x raised to m plus 1 into log x its power n whole divided by m plus 1 minus, so you can take n and divided by m plus 1 outside of integration, so it will be n divided by m plus 1, and it will be integration of, let us see, so this divided by x, so you can write it as at numerator and it will be minus 1, so it will cancels this x raised to m plus 1 to x raised to m, so that will imply, let us see, so yeah, so what is this? So this log x raised to n minus 1, so derivative, we are taking derivative, so it will be n minus 1, so it is there, so it will be x raised to m into log x its power n minus 1 dx, and this is the required reduction formula which already we have written, so that will give us fifth reduction formula. So this is the required reduction formula. So this is the end of this chapter. So I will give assignment on this chapter. So I will share assignment 1 on chapter 1 in the WhatsApp group. Yeah, Google Classroom and Teachmeet. So in next lecture we'll continue next chapter, that is integration of algebraic and rational functions. So I'll stop here.